Hello, hello, hello. This appears to be on, which is good. So, asynchronous programming in Java. You're all in the right place. Yeah, that's good. I've only got a couple of slides, and then I'm just going to go into doing some coding. We're going to run some services. We're going to do a little load test against a synchronous service versus an asynchronous service. I start off with just a quick introduction into why you might want to do this. So, it's all good and well thinking, I think Java, most of the things we do is actually synchronous. You know, the Java method call is synchronous, most of the web frameworks we use, etc. And there's definitely been a rise in popularity of asynchronous frameworks recently. So before I jump into showing you how you could do that, I first wanted to just talk for one moment about, why you might want to do it. Because if you don't need it, then it's just added complexity to your application. It's new things all of your development team need to learn. What I'm hoping to cover in my ambitious schedule is to build a service synchronously and asynchronously. Show you how to use executors futures, listenable futures, completable futures, hit it with a bunch of load, and show the difference in resource usage between the two. It is ambitious. So before we jump into the practical, I want you to start thinking about the threading model of your application. In Java, a lot of the time, we do not think about a threading model. We're often in building JEE apps or something servlet-based, and they kindly just give us a thread for the entirety of our request. What do I mean by that? I mean, you've probably implemented things that look a lot like this. A user request comes into your application. It could be an RPC call. It could be some HTTP over TCP. Doesn't matter. And your responsibility as an application developer is to have a method called, and you need to do something, hopefully some nice business value that earns your company some money, and then you have to return from that method. And that's what I mean by a synchronous programming model. If, during that request, you decide to make a call out to a database or 14 other microservices or put a message on a queue, then that thread that you were given, you will block it, typically. Now, that means that thread isn't doing anything. And this talk is about avoiding that and the reasons why you might want to avoid it. So what is the cost of a thread? Do you care? And if you're building an application which is 5 concurrent requests a second, I can pretty much guarantee you that you do not care, and you shouldn't go and use akka or Ratpack or some kind of CompletableFuture. Stick with the synchronous model that I've programmed with for years. But just aware that each thread that's lying around does use a big chunk of memory, and that's not accounted for on your heap. Right? That's your stack. To be able to look at your Java application and see how much memory that is using, that's a different area. And it also slows down other admin things inside a JVM. So if you need to do a stop-the-world pause in a garbage collection, or you're doing some profiling, or you're doing a thread dump, all of those threads need to come to a safe point. They need to come to a standstill. And it goes without saying, really, that the more threads you have, the more work that is for the JVM. And quite interestingly, if you've gone onto a cloud provider where it actually costs money for memory, and you can reduce the amount of memory you use, you can actually save money instantly by reducing the virtual machine size. Every thread you've got lying around in Java, you could kind of equate to costing you $8 a year. That's roughly how much it costs. Now, if you haven't got many concurrent requests into your application, you probably don't care. But if you've got many thousands, perhaps you're a popular website, you're the audit service for a company like Sky, where I work, then that could be many thousands of requests, concurrent requests. And suddenly then you're wasting many thousands of dollars per application, keeping all of those threads around. So the alternative is to respond asynchronously. So rather than block a thread for the entirety of your request, if you're going to make an external call, so you're going to do something which isn't CPU bound within your process, then you need to then not block that thread, give it back to the framework to use for someone else. And there are various ways you can do that, and we're going to look at a bunch today. I work at a company called Sky. Now, they allow people to watch things like Game of Thrones and football games on their iPads, maybe sitting on a toilet or whatever. So basically, I'm building lots of web services which allow you to watch television. So forget the actual television. We're talking about online television. It's like Netflix, but just for the UK. Now, if a user request comes in, then we need to do a lot of different things. We've got an old legacy service which is going to manage users, and we need to make a call out to that to get your user information. We might have a different service which calls out and gets your permissions. Are you allowed to watch sports? Are you allowed to watch Game of Thrones? If not, that's really sad. Are you trying to watch a channel which doesn't exist? And some of these calls we can just make whenever we like. There's no dependencies on them. And when we're going to code up an example of this, we can call the user service whenever we like. We don't need any more information. Same for the channel service. That's what the yellow indicates. However, our permissions service, we can't call into that until we've got information about a user. Now, that's a very common scenario I find when you're orchestrating calls to different databases and HTTP services. Some you can just call whenever, it's up to you. Some you need to sync, like, serially, do one after the other because they're chained, they have dependencies. When we're doing a synchronous programming model, it's really easy. We just do one after another, and we wait, and we can have the information available. But if we want to, say, asynchronously kick off a bunch of these calls, we need to do things like chain the call to, say, a permission service after the user service without blocking a thread waiting for the user service to come back. And to mimic that and to fit it into 50 minutes, those three services I have just hidden inside a Java class that have interfaces that look a lot like this. So for every service that we're going to do some live coding and demo to you, we can either call it synchronously. That's the one at the top. We'll start off calling things synchronously. We could call it in some type of asynchronous manner and get a future back. So that's a future that's built into the JDK. Or we could move to Guava, which are Google's libraries for Java. And we could get a listenable future back. And then finally, we'll have a look at new in Java 8. In my opinion, the best thing in Java 8 rather than Lambdas is the CompletableFuture. I can't really see you, but I was going to ask here, who uses listenable futures on a daily basis? Who uses them a lot? You might get bored. How about completable futures? Not many. And it's because we're waiting for libraries to catch up with us. A lot of library developers who make our HTTP clients, our database drivers, they need to support people using Java 6 and Java 5. So they can't use it yet, but these things are coming. So rather than show code on slides, I thought I'd just go into a demo and start coding some stuff up. So can you see this? Yes. It's big. So this is a perfect screen for doing live coding. So this is not the real sync service, which is going to allow you to watch television in the UK. It is a much simpler version. Now, I've already implemented the synchronous one because that's boring, and we probably know how to do that already. So here's the three services that I was referring to. And then let's say we want to offer an endpoint which allows us to look up users. Well, we're going to be able to do that. We're going to call into the user service, etc. The kind of caveat is, though, that each of these calls are going to inject at least, not 500 seconds, would be here all day, 500 milliseconds of latency. So if we do 3 calls sequentially, it's going to take at least 1.5 seconds. Whereas if we make some of these calls concurrent and do them in parallel, then we'd be able to reduce the time. Now, the 3 services endpoints we're going to implement, we're going to look up a user. It's going to be nice and simple. We're then going to do the permissions call. Now, this is what I mean by a dependent call. We can't call into the permissions service until we've got the user object back. We need that globally, company user ID that we all seem to have. It's probably like an auto increment inside some old database. And finally, then we could ask if that user has that permission. Now, to watch Sky Sports 1 and to watch the Premier League in the UK, then you need to have the sports permission. Now, the more complicated one which we're going to get to is when we've got 3 calls and they don't have to be chained one after another. So we can call out to the user service, which would take 500 milliseconds. We can then call out to the permission service, given that we've got the user ID back. But we also want to look up to make sure the channel exists. Now, assuming these all take 500 milliseconds, how long do we think this method would take? It's at least 1.5 seconds. But does it need to take 1.5 seconds? Probably not. So things I want to cover for doing things asynchronously are, we're going to cover these 3 things, the future, listenable future, and completable future. We're going to look at some of the most common scenarios I find when we're building services which interact with other services and databases. The async call, making an async call chained after a first one, making concurrent async calls, and then combining the results. Because if we're waiting for the channel service to come back and we're waiting for the permission service to come back, we can't actually respond to the user until they both come back. two independent asynchronous operations. And if I've got time, I'm just going to shove some load on it and reduce the number of threads available to the JVM and see how they perform differently. So rather than jump right into the service, I'll just show you the bare of it first. So we've got an async TV. So this is what we want to be able to implement by the end. All right? So if you've done JAX-RS, so it's a standardized Java way of doing, like these annotations. You might be using Spring, and that could be very similar. So, so you do a path, you do get, etc. Now, if you do not want that to be a synchronous request, you do not want to block, say, one of Jetty's or Tomcat's threads, then you need to pass in one of these, this @suspended. And the @suspended, you put on an asynchronous response. Now, the really important thing to notice about this method, and different to the other ones, is it returns void, and then it's our responsibility to call resume on this at some point. I was thinking about doing this with Ratpack, which is a bit more Oraka, but that's a bit more complicated. I think this is most similar to what most people are doing at the moment. Now, we could just hard code this. I think it's a good idea just to hard code the name. That could be who everyone wants. And that would work. But all we're doing there is doing it on the same thread, and we're not doing any blocking calls. So this isn't really going to help us. What we need to do is set up a recipe for this request. We need to compose some asynchronous operations, stick a callback at the end, and have that actually call resume. So this isn't the answer. But by the end of the talk, we should have looking up a user permissions implemented. That will involve at least 2 callouts. And then we want to do the big one, where we're making an asynchronous call out to the permissions service after the user service, and at the same time calling out to another service, which in my example is the channel service. It doesn't really matter if these were HTTP calls or database calls or anything. It's just something that leaves the JVM, right? Something which is actually going to be blocking for some amount of time that means that we wouldn't want to waste a thread for that duration. So before we jump into that, let's learn how to use executors and features and all sorts. So I've got 3 unit tests, and they implement all the functionality exactly the same way. Now, the first one is a synchronous one, which again we've done. We're only going to do the asynchronous ones live. So if we want to check someone like Batey, which is my username for Sky, has a particular permissions, this is probably how we would do it. And that'd be fine. And if we were working through a set of requirements for a service, we might start off with that. Batey has a particular permission to watch a channel. And then maybe we want to stick on, we stick on the extra call to the channel service. That's nice and easy, but remember it's taking 500 milliseconds. Turns out, eventually someone decides that's too slow. All right? Third requirement is, and that's where we're going to get going, is that we're not allowed to make blocking calls that are independent one after another. We have to make them concurrent. So if I were to run this test right now, JUnit will nicely tell me how long it took. And maybe that one's not big enough, but in the bottom corner there, it took 1.5 seconds, which is what we're expecting. So what happens if we do something similar? Say we're going to do the same test, but we don't want that to happen. So you see now I've actually added in a timeout of 1.2 seconds. So if we continue to do this in a synchronous blocking serial manner, then this is not going to work. And look at IntelliJ telling me off for having duplicate code. I think IntelliJ gets too clever. Right, so what do we need to do? We need to make this call, the call to the channel service, happen at the same time. So we can't do it here. If we don't use any fancy tools, we're probably just going to have to create a thread and put it in there and kick it off somehow. Now, I'm guessing a lot of people, before we jump onto features and things, have played with an executor service. So that's Java's abstraction to allow us to kick off work on different threads. And there's a nice factory method which is going to allow us to do that. If we want to submit some work to that, we have 2 options. We can pass in a runnable or we can pass in a callable. Right? And if we look at a runnable, this has been around forever. Right? I'm sure you've all seen runnable. You're probably very bored right now. I know what a runnable is, Chris. Carry on. Anyway, it doesn't take anything in, and it doesn't return anything. So if we wanted to get our channel object out of a runnable, we'd have to write it to some, shared mutable state between 2 threads. So that's not much fun. I don't want to have to do that. So what about the callable? So the callable, which was added in Java 1.5 by Mr. Doug Lee, it's very similar, except it returns something. So this type parameter here, v, that allows us to actually get something out of a task which we've submitted to an executor service. So it's a functional interface, so we can use a Lambda for it, and we can go out to the channel service. We haven't learned how to use these other ones yet, so we're just going to use the synchronous one, and then Sky Sports 1, because I watch a lot of football. We can get that out. So if you've used this before, you probably know what this method is going to give us. It's going to give us a future. Now, a future in Java represents an asynchronous computation. It hasn't completed yet. But what we need to do is get something out of that. So if we look at a future, what methods does it have? Well, not many. Is done, is cancelled, get. But we can call get, and if we have a look at the Java doc for that, it waits, if necessary, this is just at the top here, for it to complete. Now that sounds an awful lot like blocking, and it is. So if we were to kick this off on a different thread so we could do it concurrently, and we were to just grab it out of there, do we think this test is going to pass? Maybe, yes, no. Well, not really. It's still going to time out. But the only thing we need to do once we've introduced a future for that call is to move this down below. And that's because we can do this blocking work before basically waiting for this one to be done, the call to the channel service. And that kind of works. That's OK. I find this kind of code pretty hard to reason about. And this passes. And it completes in 1.73, 1 second and 73 milliseconds. So we're well under the 1 second and 200 milliseconds now. But I find this code confusing because it mixes two paradigms. We've got futures on the one hand, and then we've got some blocking calls. So if I'm trying to work out what's going on, looking at this code in a week or two, I would find that pretty hard. So we're going to leave our synchronous test and just make everything futures. Why not? All this code's on GitHub if you want to play with it later, by the way. So if we want to make everything with futures, we could do that. Because remember, some kind person made all of our services be asynchronous. So we can go to the user's service, we can look up a user asynchronously, and that's going to give us back a feature. Then we can go to the permission service asynchronously. Permissions. We can go to permissions, and we can look up the permissions. No, we don't want that one. We want permissions async. Right. What do I pass in here? I'm stuck, because I actually need the user. And I can't get the user out at the moment. The only way I can get the user out is to call get. And I'm kind of back at square one, but let's do that. Why not? Let's get rid of that. So this will actually block for 500 milliseconds. So this definitely isn't the end solution. But then let's say we want to, we need the user permissions out of there because we've got an assertion down there. So I'm going to get the user permissions out of there. And then we can't forget about our pure channel service. We need our channel out of there. I'm going to look it up asynchronously again. I'm still watching Sky Sports 1. I don't have a very varied life. And then finally, I can pull out the channel because that'll be done. Right. Do we think this is going to pass? So we've got the same timeout as before. Well, I don't think it's going to. I hope it doesn't. Because again, we've still done the get sequentially, so it's still taking 1.5 seconds. We haven't kicked off the channel service until our user permission service has come back. But because we've done everything with futures, it is super trivial to fix it. You can say everything that you want to happen at the start of your user request coming into your application, you can kick those off, and then you can just decide in what order you want to block and wait for them. Now, we're still going to aim for no blocking whatsoever, but this is definitely a step in the right direction. So we've done everything with futures. Null pointer exception, channel, user. Oh, you're right. I don't even know my own username. There's only one user. Sky TV have one customer, that is me. And that's the only one that actually returns a user. There you go, help your speaker. Shout out when you make silly mistakes. Right, so that passes. But that's not going to help us implement our final service. If we go back to our requirements, the fourth requirement, we've done the concurrency thing. We've made it half a second quicker. What we haven't done is enabled us to do it without blocking any threads. We're still calling .get. For the rest of this presentation, I am banned from calling get on any feature whatsoever. So that is where the listenable feature comes in. So a few people did put their hand up when I mention listenable features. They've been around for quite some time. They're from Google. And before the completable feature came along, I'd say they're a de facto standard. If you look up a async HTTP client in Java or an async database driver, they actually often don't return the JDK feature. They often return this. Now, if we have a look at the listenable feature, the first thing to note is it does extend the JDK feature. So that's nice. Everything we've learned so far about features, we can still use. So that is fantastic. And we can still do it blocking if we wanted with listenable features. Or we can pass in listenable features to APIs that already take JDK features. But if you have a normal feature, you will be blocking at some point. Right. Who here has done a lot of callback programming? Yeah? So we're going to try it with callbacks first. So this is where, rather than blocking, you can register some code to execute whenever that feature completes. So the user comes back from the user service, we kick off some code, which then calls the permission service and so on and so forth. So I could get a listenable feature out of my user service. Look up listenable. Let IntelliJ do the typing for us. Now, we're not allowed to call get. That's banned. But for listenable features, there's a set of static methods on this features object which allows us to do some really cool stuff. And the first one is to add callbacks. So you can add a callback to a listenable feature. And let's have a look at what one of those is. Not a feature. Callback. So we've got two cases. We have two methods to implement. If it fails, perhaps we could return a 500, or if it succeeds. Now, the amazing thing about this is that we have hold of the user ID. That's exactly what we want. And the great thing is adding this callback does not block the current thread. Our current thread would just tootle on doing whatever it does. And because this isn't a JUnit test, it would actually end the test and never execute this code. But we can then go to the permission service. We're using listenable features now, so we'll stick to that. And we'll get this back. We've been able to chain another asynchronous computation. Now, the problem is we're going to end up with another listenable feature. So this is going to be a listenable feature for permissions. Now, we want to check I've got sports permission, but I can't block. I'm not allowed to call get to get it out. So what do I need to do? Add another callback. It becomes ugly. It becomes big. So I'm going to add a callback. And then finally, I can do result dot, has permission. I can see, is Chris allowed to watch the football or the Formula 1? And of course, this is the point where I'd actually call, async response.resume to actually send the user request back. Now, this gets big. This was only 2 callbacks. I mean, this looks bigger because the future callback from Guava isn't a functional interface. If it was, it would look a bit smaller. But we're going to give up with callbacks for now. Regardless of whether you're using listenable features, you're using completable features, observables from RxJava, whichever tool you actually decide to do, the piece of functionality you want to look for is to be able to transform asynchronous computations without blocking and without using callbacks. And this is often called compose or transform. It's actually, they allow us to do it. Let me just steal a little initial one. Guava allows us to do it with what's called a transform. So we can do transform, and we actually want to transform async. The completable feature API and the listenable feature API, async means something slightly different, which I'll explain as I go along. So you pass in a feature, and then you pass in an asynchronous function. Now, in this context, asynchronous function just means something which returns yet another listenable feature. So I can create one of those, async function. Now, that async function transforms a user, which is the type of our first request, and we want to turn it into a permissions. So we've got a user, and then we want to turn it into a permissions. OK, this looks good. We've got our user back. Remember, that was exactly what we needed last time. We needed the user. We've got the raw user object as the input. And then we can go to the permissions. We can look up the permissions listenable, and we can access that ID. Now, you might be thinking this still looks a little bit ugly. But what we can actually do is we can assign it to another variable. So rather than chaining the callbacks, we end up with a listenable feature which represents both computations. This will only complete. If someone did call get, this would only complete once both of them are done. An async function is a functional interface. So we can use a lot less characters. So we don't need to use the anonymous class. It starts to look like this. And this is the piece of functionality which you're going to look for if you're going to move to a more asynchronous programming model. We want to transform something asynchronously. Now, what else do we need to do? We wanted to make an independent call to the channel service without blocking. So this isn't chained onto the user service or the permission service. This is a completely orthogonal request. We can kick this off whenever. And because these top two lines that we've done don't block, then we can just type it down here. We don't need to put it any higher. Now we're going to go to the channel service, and we're going to get the listenable feature this time. I'm still watching Sky Sports 1. I'm still thinking I wish I'd picked a shorter channel name. This is the conundrum which you're then going to have. How on earth do we combine these things? Because we can't respond to the user until all of these three async requests out to database or queuing, whatever they are complete. So how do we turn these 2 or 3 listenable features into one so we can put a callback on to work out when it's done? Now, there are a few ways to do this. Probably the simplest is to use the all as list, or you might see this as more of a sequence. And you can pass in as many listenable features as you like. You could go crazy. And we could pass in the channel. We can pass in the permissions. And that is actually going to give us yet another listenable feature. So if you're sick of these guys, then I'm sorry. And what I like to think of as this one is it's the feature which represents the whole operation. So this will only complete, if someone to call get on this feature would only complete once everything is done. That's what we'd like to actually add a callback on to respond, to the user, say, web request. And the only unfortunate thing is it has turned it into a list of objects. Now, there are various type-safe ways of doing this in Guava, but we're actually going to jump to completable features where it's much easier. But one last thing to show you before we move on to completable features is we can transform things without involving another callout, another asynchronous operation, another thing which returns a listenable feature. So I could take in the whole operation, and then I can pass in a function which takes a list of objects, which is not good, and maybe gives me a nice result object like this. Something which has a channel in and some types. We like types in Java. And I actually already wrote that function because it was really boring. It basically takes the things out of the list and puts it into the result object. But we're gonna make that more type safe, don't worry. And at this point, we're kind of done. The only thing we need to do is actually do something with the result, right? So we've got this nice result. We've got this nice feature which represents all of that complex calls out to various services. At that point, it's a great idea. Now, some frameworks will accept a feature back, like Spring Async and things. But otherwise, we just want to add a callback to the final result. This time, we're not going to have nested callbacks. We're just going to have a single callback. And we can get things like we can get the channel out. We could check the channels there. We could get the permissions out. And we could actually call, has permissions, make sure he's got sports. And at that point, yeah, we could return. And we haven't blocked a single thread. It's quite a lot of code. And we're going to see these chained together in a much smaller amount of code soon. But we've done an asynchronous callout. We've chained another asynchronous callout at the same, when it finishes. We've done another one to the channel service at the same time. And then finally, we've combined all that into a single feature which represents this entire user operation. Now, the more you do this type of programming, the more you get used to it. If you've done a lot of Scala and things, you'll probably be more used to this style. Now, one problem I do see with this, though, is the fact that we have a dependency on Guava. As I said, some async clients, some database drivers, etc., have actually put something not in the JDK in their API. I work with Cassandra a lot, and the listenable feature is what it gives back from the database driver. But I'm sure most people here have had a Guava class path problem. And not to mention, you're going to get more people as the completable feature has lasted for longer using it, and more APIs will support it. So let's quickly flip it over to the completable feature, but we're looking for the same bits of functionality. We're looking for chaining, doing things at the same time, and combining two different, say, asynchronous computations. And it's the completable feature that we can actually finish off with and actually implement the service with and then see how it behaves. So I'm going to jump to the last one that times out and just show you that one. And virtually that code we can use inside the service. So the completable feature. let's actually step into it first. Let's go and have a look at the source code. Completable. So again, it extends from a future. So we haven't lost any knowledge yet. We can still apply everything we did at the start of the talk. It also extends something called a completion stage, where all the really funky methods are that we're going to use over the next few minutes. Don't worry too much about that. Just know that most things take in a completion stage rather than like an actual completable feature. So let's implement our service. Let's do the same interaction again. So we're obviously going to start off getting a user object from our user service. And we're going to look it up completable this time, and get that. We need to change something off that, don't we? We can't just do that. We need to do something after it. So normally I would do this in one line, but it's interesting to see the types if we do it one at a time. Now, we used the word transform before. We're going to use the word compose. If it's got the word compose in, it means that it wants you to turn it into another completable feature. And here, we have a function which basically takes in a user object and wants to return a completable feature of your type. And that's exactly what we want. We want to use that user object, get the user ID, and return it. And that will give us, IntelliJ generate that. No, we don't do that. That will generate a completable feature of type permissions. Great. So the last thing we want to do is make a call to the channel service. Now that's nice and easy. So we can look up the channel, we can do it completably. Right, that's going to give us a completable feature of type channel. Now we're back to that hard part, or the slightly harder part, of bringing it all together. Now, the completable feature has a really nice API for this, in my opinion. Oops, typoed that, but what that allows us to do is combine many features. So if it's got the word combine in, it's taking multiple independent things and turning it into a feature that we can then do something with. So I can pass in this channel service, and what it's going to ask us for is another one of the functions, a by function. Now that takes two things, and you have to return one thing. And so it takes in the types of the completable features. So we've got it takes in a permission, it takes in a channel, and we get to return whatever we like. And I suggest we return a result object, because we've got that, and then we can just stick in the channel, we can stick in the permissions. And that's actually going to give us a final completable feature of type result. So that's the thing which we probably want to add a callback to. So we're actually done with it. So we've taken all of these separate completable features, turned them into one, and then the way to add a callback in that is uses the word applied. So if it's got the word apply on, except, it's basically the equivalent of a callback inside Guava. And you can do it asynchronously. Asynchronous means something slightly different for completable features. It means that it's going to do it on not the thread which completes the feature. So you can actually pass an executor into virtually all the methods which take async, or they can use the default fork join pool. So then except, we get given our result, and then we can do what we want with it, right? I can put this on a couple of lines just so we can play with it. We can get the channel out of it, and we can make sure that's not null. We could get the result, and we could, check the permissions again. We've done this a few times now, so it's probably getting boring. Right. I think we've got enough knowledge now to go and build our service. We know how to kick off things. We know how to combine things. It's about time we do it, and then we see how many threads we need to actually service, say, many hundreds of requests a second. So let's jump into our async service. What I'm going to do is we're going to do some more coding. We're then going to run it. We're going to have a look inside mission control, see how many threads it's using. We'll then reduce the number of threads and see whether it can still achieve the same load, etc. So we've probably got time to implement a couple of endpoints, or real endpoints. And let's do it with the completable feature because it's my favorite. So I'm going to go to this is a nice, easy one. Make this a bit bigger. So we're going to go to out to a user service. We're going to look it up from a completable feature. This time the username is actually passed into us. It's not just me anymore, unfortunately. And then we need to respond now. We don't have any fancy extra calls to make. We just need to make one external call without blocking. So at that point, we use the callback. and we can accept. We can do then accept. That actually gives us the user, and then we can go to this asynchronous response that JAX-RS is giving us, and then we can call resume, and we can say user.getName. And why don't we actually give that a go just to make sure any of this works? So I'm going to restart this. It's a small drop wizard application that you can play with. It uses Jetty and Jersey, which is the reference implementation for JAX-RS. And I can go to the command line, and I can hit it with curl. So I'm going to time things just to see how long they take. I've just timed time. That's interesting. So I can time curl, do -v, localhost. This is running on port 9080. Now I've already got everything implemented synchronously. So if I want to hit the async one, I go async, and I go user, and then me. That takes a while, because remember, each of those services that we're interacting with, they're all a bit slow. They all take about 500 milliseconds. So that actually took 0.5 seconds, if you can see it down the bottom here. Let me send it to the top of the screen. So the real time taken is 0.5 seconds. Right? If we hit the synchronous service, would we expect it to be any quicker, any slower? It's about the same, right? Because we're doing the same thing. We're just, whether we're blocking a thread while that 0.5 seconds is happening. That's not very exciting. Let's move on to the more complicated one. So let's go right through to the one which does all the callouts. So we can go to the users. We can look up a user from a CompletableFuture, right? We can then make a call out. We need to chain up. We need to basically set up a recipe. We can then make a call out, which means we use compose to then call out to which service? The permission service. You know, and we actually get hold of the user ID without blocking. We're kind of done, right? We're kind of done with that one. At the same time, we know how to make another call out at the same time. It's like a different chain. So we can go to the channel service. We can look up a channel. This time, we're not just watching Sky Sports 1, even though it's the only one that exists in this application. And at that point, we've kicked off all of the computations that we need to make. So this one is this is the CompletableFuture for the permissions. And then this is the one for the channel. Now we need to combine these, right? Oops. Oh, it's not working. We need to combine it, so I'll just type this. Let's see. Now how do we combine two CompletableFutures? Well, it's got the word combined, so that's nice and easy. So we take either or, doesn't matter which we go first. We then combine them, not complete them. I'm not doing promises today. Take the channel, C channel, which I've typoed. And then finally, that will actually represent our final thing, right? But maybe we don't like the types, etc. So when we combine it, we need to turn it into that result object that we had. So that's going to take in a permissions and a channel, and then we can go, new result. We can pass in our channels and our permissions. And we're definitely done now, right? We've kicked everything off. All we need to do is respond to the user when everything's finished. So we can do the then accept. We're going to get given the result, which is going to contain all the information we need. It's going to contain the channel. It's going to contain the permissions. And at that point, we need to decide what on earth we're implementing. And it is basically checking the channel exists and checking the user has the permission. So we could do async response.resume. I'm just going to say result.getChannel is not equal to null. And we want to make sure that we've got the permission. So the result.getPermissions.has permission, and then the permission that was passed into the service. And then, we can stick that on a different line so it doesn't look quite as ugly. So that should work. We've kicked off one computation, we've chained another, we've kicked off the channel computation at the same time, then we've combined the result, and when everything is done, we then send a response back. Will it work? So I'm just going to quickly restart that. No. Will it work? I don't want to execute that. So I'm going to kick off the service again. We're going to go and we're going to say this is implemented asynchronously and synchronously. We'll try the synchronous one first. So we're going to watch channel, and the endpoint was user permission channel. So ch Batey, user permission sports, and then channel, which is Sky Sports 1. I'm not trying to build a REST API. So that comes back, and it takes 1.6 seconds, right? Because we had 3 calls out, all of which took 500 milliseconds. And that's because I hit the synchronous endpoint, where if I hit the asynchronous one, unless I've made a big mistake in the last 5 minutes, it should take just over a second, because we're doing that channel call at the same time. So same behavior, but it's much quicker. Also, true is just what I come back with because it's there. Whereas if I were to try and watch the channel cats, which unfortunately doesn't exist in Sky, it would come back with false, but still take a second. So that's one of the benefits, right? We're seeing those faster response times because as soon as we're programming this way, it's very easy to make the calls out concurrent. But the other benefit, and probably the more important one a lot of the time, is if you have a large number of concurrent requests, not blocking those threads and wasting those resources. So if you're not familiar with Java Mission Control, I'm just going to show you it briefly. Bit of Oracle advertising. Right, so I'm not going to do any flight recording. I'm just going to show you some basic stats about the JVM. The first is the memory usage, which is this one on the bottom here. So we're not using much memory, and actually this is heap. This doesn't include anything else. So often just looking at memory usage on this initial default dashboard in here can be quite misleading. We can go to the threads tab and we can see live number of threads. Is that line? It's more visible than on my laptop. So without changing any configuration, this is the default configuration for Jetty, which is a lot like Tomcat if you haven't used it, when it's embedded inside a Dropwizard app. It's using about 30 threads before it's actually received any requests. Some of those will be GC, compiler threads, all sorts. Another thing I'm going to play around with, you can do all of this stuff from J command as well, but this is prettier and more colorful, is execute the memory stats for it. So this VM native memory stats will tell you about areas other than the heap. So we have our heap here on the top. Let me make that that's bigger. Let's bring this up. But we've also got the amount of memory used for threads. So actually, we've got a total of 42 threads, and we're using here, you can see, about 42 megabytes of memory for the threads. Now I'm going to use Apache Benchmark, which is just a really noddy tool for generating some HTTP load. Don't suggest you really use this for your proper load testing, etc. But it's useful. So Apache Benchmark here, let me just bring this higher in case you can't see. So Apache Benchmark allows us to specify the concurrency level. This is how many concurrent requests we're going to send to this application, and how many requests. So I don't want to waste too much of your time, so we're only going to make 1,000 requests. Now, let's forget the complicated one with multiple calls. Let's just look at the really simple one, which makes one call out to the user service. We could start off with the synchronous endpoint. That's the one that blocks the Jetty thread, whenever it's waiting for a user to come back. And we can see what type of performance we get. I'll make this bigger again. Now, Apache Benchmark, it prints out some stuff as it's making the requests. It went through, it did those 1,000 requests pretty quickly. It gives you some percentiles, so we can see the median was 505 milliseconds. And remember, this was just the one call out. So about 500 milliseconds is what we were expecting. We've got the slowest response time was 649. Now, if we jump back into Java Mission Control, we look at the memory usage. It's gone up quite a bit, but we'll look at that in a bit. We're going to threads is what I meant to look at. Now, this line has spiked up a lot. So we started off with about 30 threads, and we've spiked up to 130 threads. And that's because Jetty has created a new thread for every single concurrent request. And then that thread has been blocked, waiting for the user service to come back. And we're using more heap, evidently, but we're also using a lot more memory for threads. Now, this still says 42 megabytes, so maybe I'm a liar, but you need to re-execute it. And now we can see we've got 144 threads in the JVM, and we're using nearly 150 megabytes of memory just for the threads. And what are they doing? They're just sitting there, waiting for the user service to slowly come back. So do we think the asynchronous service is going to be any different? Well, just to get rid of all those threads and give us a reasonably clean state, we're not warming up the JVM or anything, so we're expecting, this not to be particularly fast. But we're talking orders of magnitudes, number of threads. Does it take 500 milliseconds or 1,000 milliseconds? We'll make sure that's started up again. I'll just hit a couple of curls. So unfortunately, the cats channel still doesn't exist. So that works, but everything seems to be working. And now this time, I'm going to reconnect it, because I've closed the JVM. So obviously, this says disconnected. So I'm going to reconnect back. I'm going to have a quick look at the memory usage. It's fine. Have a look at the threads. We're back at, obviously, we've restarted, so we're back at kind of the default initial amount of threads of about 30. We can execute our VM native memory again, and we can get hold of, like, say, how much memory has been used for threads, which is about the same as it was before. We've got about 42 megabytes. Now we're going to hit it again, and the only difference we're going to do is hit the asynchronous endpoint. And this is the same functionality. There's no functional difference between these two applications. We want to see how it behaves a bit differently. So it finishes off the request in about the same time. We've got a straggler there, actually. Maybe I'd had it running quite a bit before I hit it the first time with the synchronous app, so it should be about the same. Hit it once more. So we're down at like the 50th percentile of 502 milliseconds and the 100%, the max at 581. So I'm going to pop back into Oracle Mission Control, and I'm going to have a look at how many threads were created, etc., to manage that. Because we've got roughly the same performance. So it's still a jump, right? We've still jumped up, not as many. If you can't see the numbers on the slide, on the side there, on the y-axis, it's jumped up around 30 threads rather than 100. And that's because we've hit it concurrently with 100 requests. Even that small bit of code setting up those completable futures, it was still being used for a short amount of time. So it still had to create quite a few threads. So I classify that as a failure. I wanted to do better than that. If I execute my, get my memory stats back, number of threads is 72, which you can see here. And then the amount of memory used for threads is about 72 megabytes. So we've done better, but I really want to do much better than that. I still don't want to waste all my $8. I'm from the north of England, and in the north of England, we don't like to spend money. So I need to basically tell DropWizard and then to tell Jetty not to create many threads. They need to trust me. Everything I'm doing is non-blocking. I'm not going to waste any of your threads. So don't create 30 threads just because the first 29 are in use. And you can do that by just overriding the configuration. So DropWizard also has an admin endpoint. We're going to knock down the number of acceptors and selector threads. So acceptor threads inside Jetty are the ones which actually accept the TCP connection. Selectors are the one which actually reads off the socket. And then it's our request threads that actually come into our methods, that come into those things annotated with get. And what I want to do is only make 5 threads total. Even if I've got 1 million current requests, I only want to hit it with 5. So let's try that. That is going to require a restart. And then I'll have to remember to reconnect to the new JVM. So it's this one. Let's have a look at the number of threads again. So we've got this nice live thread graph. Oh, we're lower, so we haven't eagerly created quite as many threads. So we're at about 22, so a little bit lower. Now, what do we think is going to happen when we hit the synchronous endpoint? Are we going to get the same kind of behavior where we could complete 1,000 requests really quickly? Who thinks it's going to be the same? Not the same. Doesn't care. Right. So Apache Benchmark, quite fittingly, says be patient. Because that's exactly what we're going to have to be. We've only got 5 request threads, and they're all blocked calling the user service. So our actual throughput is going to be very bad. And we haven't got time to sit and wait for these 1,000 requests to complete. And we can see the response times are very slowly, because Jetty does queue up requests. So Apache Benchmark will have still sent them, and they'll be sitting in a queue somewhere. Now, I'm going to restart the JVM one last time, but before I do that, I'll just show you, look, we have actually achieved our goal of saving money in Amazon. We've only created a very small number of threads this time. We haven't had that big spike. So even though our application is terrible, we have managed to save some money. Let's reboot it one more time just to remove any rubbish. Reboot. I think it should be up and running. That's fine. Right, so we're going to do it again, same number of requests, but we're going to hit it asynchronously. Now the difference here is because we're not wasting that thread block to the user service, we're giving that thread back to Jetty to use for another request, we can achieve very similar performance. Now that was a very fresh JVM, so we can see it's a little bit slower at the max and the 99th and 90th percentile. Runs a few times. That's never been slow when I practice it. It normally does get back around to around 500 milliseconds. And I forgot to reconnect this because I'm an idiot, but we can reconnect it and just so that there's not a big spike of threads. Like we're actually still at 20 odd threads, but we're servicing those 1,000 requests quite quickly. So that's it for now. We're running out of time. My last few kind of points is completable futures. I'm sure a lot of people have played with RxJava and Ratpack and all these really new cool tools. Make sure I think you have one of these requirements. You either need to inject some concurrent, some parallelism, so you can actually reduce your elapsed time, or you do actually need to avoid this cost. I see a lot of talks, etc., saying async is the future. That's like my title. But it's only the future for people who actually need to satisfy large numbers of concurrent requests. And on that note, thank you very much. I'll stick around after for questions because we're completely out of time. Thank you very much.